Hello dear students. So we will be discussing about the multiple choice questions of the lesson electrochemistry. In that, the first given question is, which of the following statements is correct? Option A, E cell and delta Rg of cell reaction both are extensive properties. Option B, E cell and delta Rg, that is change in Gibbs free energy of a reaction, both are intensive properties. Option C, E cell is an intensive property while delta Rg of cell reaction is an extensive property. And option D, E cell is an extensive property while delta Rg of cell reaction is an intensive property. So before finding out the answer of it, the meaning of the term extensive property is that it depends on the extensive property means depends on the quantity of matter present in the system. Whereas intensive means it is independent of the quantity of matter present in the system. So extensive property is dependent on the quantity of matter present in the system. Intensive means it is independent of the quantity of matter present in the system. Now if at all we consider, so we'll take a simple equation, that is Daniell cell equation. So if at all we consider, in Daniell cell, anode is zinc and cathode is copper. And if you consider their cell reactions, here we see that zinc undergoes oxidation forming Zn2 plus of 2 electron, and copper ion undergoes reduction accepting 2 electrons and forming copper. And according to the electrochemical series, the reduction potential of zinc is equal to minus of 0.76 volt, and electrode potential of copper, that is reduction potential of copper, is 0.34 volt. So if at all we calculate here E naught of a cell, so E naught of a cell is calculated as E naught of cathode minus E naught of anode, and here we get it as E naught of cathode is 0 plus of 0.34 volt and E naught of anode is minus of 0, that is minus into minus of 0.76 volt. So when you calculate it, you get it as 1.1 volt. So this is what we see for 1 mole of our zinc. The same if you consider, if at all I will consider that instead of 1 mole of zinc, I am having 2 moles of zinc reacting with 2 moles of copper ion and resulting in the formation of 2 moles of zinc ion and 2 moles of copper. So the number of electrons here, they become equal to 4. That is totally 4 are lost and 4 are gained. But the EMF of a cell will not change. It will remain 1.1 volt irrespective of the number of moles of the metal participating in the reaction and irrespective of the number of electrons taking place in the reaction or participating in the reaction. Thus this EMF of a cell, it is independent of the number of moles of reactant and products as well as the number of electrons participating in the reaction. And since it is independent, we can say that E cell is an intensive property. E cell is an intensive property as it is independent of the quantity of matter present in the system. So here if you consider E cell, we have come to this conclusion. The E cell value does not change. Similarly, since I have taken here 2 moles, so just to balance the equation I need to multiply this overall by 2. This overall by 2. So to balance the equation we can multiply the electrode reactions by 2. But we cannot multiply the reduction potentials. They will remain same whether you take 2 moles of zinc or 100 moles of zinc or any number of moles you take. The value of E reduction potential will remain the same. There will be no change in this values. Thus, E cell is an intensive property. But if we consider Gibbs free energy change, Gibbs free energy change is given by the equation minus NF E naught cell, or G naught equal to E naught cell, or even you can write it as delta RG is equal to minus N E cell. So E cell value is constant, F value is also constant. What determines the reaction here? N value. N value, if it is 2, your delta G value will be different. If you are increasing the number of moles of reactant, you can see that the number of moles of electrons involved in the reaction also change. For 1 mole of zinc, it was exchange of 2 electrons, and now for 2 moles of zinc, it becomes exchange of 4 electrons. Thus, for 2 moles of zinc, our N value would become 4 and delta G value would change. Thus, the value of Gibbs free energy depends on number of electrons, participating in a reaction, or we can say more specifically in a redox reaction. And since it is dependent, if it is dependent, we call it as extensive property. So let us be clear. If it is independent, it will be very easy to remember. If it is independent, it is intensive property, and if it is dependent, it is extensive property. And we come to the conclusion that E naught cell is not dependent, so it is in intensive property, and delta RG is dependent on electrons, so it is extensive property. And we'll refer NCERT also for this. So if you look at a sentence here, so here you can see that a sentence is given. It may be remembered that E cell is an intensive parameter, but delta RG is an extensive parameter, thermodynamic property, and its value depends on N. So the question asked is based on the concept given in NCERT textbook. So you can refer it. So here based on this, if you consider the question, so which answer would be correct here? Thus, the correct answer is option C, which says that E cell is an intensive property while delta RG of a cell reaction is an extensive property, because delta RG depends on N value, whereas E cell is independent of N value. So the correct answer for this is option C. So if we go with the second question, the second question given here is the difference between the electrode potentials of 2 electrodes when no current is drawn through the cell is called? The difference between the electrode potential of two electrodes is called cell potential. But when no current is drawn through the cell, it is called as cell EMF. So the correct answer for this is option B. So again, we'll refer NCERT to understand this. So if we look here, the sentence given is the potential difference between the two electrodes of a galvanic cell is called cell potential and is measured in volts. And the same cell potential, which is the difference between the electrode potentials of the cathode and anode, it is called the cell electromotive force, that is EMF of the cell, when no current is drawn through the cell. So the same conceptual question which is given in NCERT itself is asked as a multiple choice question. Hence, the correct answer for question 2 is option B, cell EMF, where EMF is nothing but electromotive force. Yes, if we consider the next question now, that is, which of the following statement is not correct about an inert electrode in a cell? So the inert electrode, so the first meaning of inert means non-reactive. Non-reactive, जो electrode react नहीं होता है, ಯಾವ electrode react ಆಗೋದಿಲ್ಲ, ಅದಕ್ಕೆ non-reactive electrode ಅಂತ ಹೇಳ್ತಾರೆ. So the first sentence given is, it does not participate in the cell reaction. Obviously, non-reactive ಇದ್ದಿದ್ದಕ್ಕೆ it won't participate in the cell reaction. It provides a surface either for oxidation or reduction reaction. Yes, that's the work of electrode. ಯಾವುದಾದ್ರೂ electrode ಇದ್ರೆ either it will undergo oxidation if it is acting as anode, and reduction if it is acting as cathode. Second point was regarding its oxidation and reduction reaction. Third, it provides a surface for conduction of electron. Yes, it's a sentence given again in NCERT that it acts as a sink of or sink for electrons. ಅಂದ್ರೆ electrons ಅನ್ನ provide ಮಾಡಬಹುದು, conduction of electrons ಅನ್ನ provide ಮಾಡಬಹುದು. Either oxidation ಅಂದ್ರೆ loss of electrons, cathode ಅಂದ್ರೆ reduction, that is gain of electrons. D option, it provides a surface for redox reaction. It cannot carry out both the reactions simultaneously onto it. Either it can carry out reduction or it can carry out oxidation, but not both the reactions at once. Hence, the incorrect, that is the statement which is not correct here, is option D. Remaining all statements, that is option A is correct, option B is correct, C is also correct. So the correct statement is option D. It provides a surface, the correct answer is option D. It provides a surface for redox reaction, but it's not a correct sentence according to an inert electrode. So let us compare it again to the NCERT textbook. So if we consider the NCERT textbook, you can see here, product of electrolysis depend on the nature of material being electrolyzed and the type of electrodes being used. So the first condition of the type of electrode what they have given is, if the electrode is inert, example platinum or gold, it does not participate in the chemical reaction and acts only as a source or sink for electrons. Thus we can say that it is not participating in chemical reaction, it is just providing electrons, and it means either for oxidation reaction or for reduction reaction, but not both the reaction at once. Hence, according to it, the correct answer is option D, that is, it provides a surface for redox reaction is not a correct statement or is an incorrect statement. So we'll consider the next question, that is the fourth question. An electrochemical cell can behave like an electrolytic cell when? So we'll try to understand the difference here. Electrolytic cell means here conversion of electrical energy. Electrical energy is converted to chemical energy. And conversion of electrical energy to chemical energy does not occur spontaneously. It's a non-spontaneous process. And if you refer the video of synopsis regarding electrochemistry topic, you can recall that there we have studied if it is at equilibrium, if the reaction is at equilibrium, the EMF of a cell becomes equal to 0. That is for any galvanic cell if you consider. In case if the EMF of a cell is greater than E external, we'll take example of Daniell cell. So the Daniell cell, E cell we have calculated in the first question. It was equal to 1.1 volt. So if you consider if 1.1 volt is greater than the external current applied, then it is acting as an galvanic, or you can say it as voltaic cell. Now what does this means? Again we'll recall conversion of chemical energy to electrical energy. And conversion of chemical energy to electrical energy occurs spontaneously. Now, if the E external is greater than E cell, that means the current given is greater, the current produced is less than the current supplied, we can say that here it is acting as an electrolytic cell. Now why it is acting as an electrolytic cell? Because which reaction is carried out here now? Reverse reaction of that of galvanic cell. And in first PU you have studied that if forward reaction is spontaneous, the reverse reaction becomes here non-spontaneous. And if it is a non-spontaneous process, it means electrical energy is getting converted to chemical energy, and if electrical energy is converted to chemical energy, it will behave like which cell? Electrolytic cell. So the correct answer for question number 4 is option C. And if we consider the D option, here they are saying that E cell is equal to E external. If E cell is equal to E external, there is no flow of electrons and there is no chemical reaction occurring. Thus, here it's neither a galvanic cell nor a electrolytic cell. Here we can say it is at equilibrium, here behaving as galvanic cell, here it is behaving as electrolytic cell, and here there is no reaction occurring. Thus, the correct answer for question 4 is option C. E external greater than E cell. We'll go with the next question, that is the fifth one. When same electric current, or if you add a word, when same amount of electric current is passed through the solution of different electrolytes in series, the amount of elements deposited on the electrode are in the ratio of their equivalent weights. And this is a direct question which we can consider is nothing but Faraday's second law of electrolysis. So this is a question based on Faraday's second law of electrolysis, which says that when you pass same amount of electric current, whatever mass of the substance is deposited on the electrode is in the ratio of their equivalent weight. So if at all we consider this mathematical expression, it is based on Faraday's second law of electrolysis, and hence here the correct option is option D, that is equivalent weight. So again, for this we'll refer NCERT. Yes, if we consider in the NCERT book, if you look at the statement given, it is given here, the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weight. And chemical equivalent weight you can calculate by atomic mass of metal and number of electrons required to reduce the cation. And it is written as second law. Which second law? Second law of Faraday's laws of electrolysis. So the correct answer for the previous question is option D, equivalent weight. Yes, so this becomes your fifth question. We'll go with the next one. So the sixth question states that the number of Faradays required to reduce 1 mole of Cu2 plus to metallic copper is. So reduction reaction. Reduction reaction means what here? Gain of electrons. Gain of electrons is called as reduction reaction. Cu2 plus ion plus of 2 electron results in the formation of Cu in solid state. So to reduce 1 mole of copper ion to metallic copper, how many electrons or how many moles of electrons are required? 2 moles of electrons are required. So a simple relation here we can write it as Q equal to NF. Q is the quantity of electricity required to deposit the given number of moles of copper. So Q becomes equal to number of moles of electrons are 2. So the number of Faradays required to reduce 1 mole of copper to ion to metallic copper is 2, and hence the correct answer is option B, 2. So the next question is 7th question, that is the quantity of charge required to obtain 1 mole of aluminium from Al2O3 is. So if you consider Al2O3, in Al2O3 aluminium, we have 2 aluminium with a charge of +3 and 3 oxygens with a charge of 2 minus. Now here 2 moles of aluminium ion we are having, but as per the question asked is quantity of charge required to obtain 1 mole of aluminium. So 1 mole of aluminium means again we want this Al3 plus in the form of Al. We don't want 2, we want only 1 mole. So Al3 plus from +3 to 0 oxidation state means it should gain 3 electrons. Again it is reaction. Which reaction? Reduction reaction. That is nothing but what do we say? What happens in reduction reaction? Gain of electrons. Thus we say that it is gaining 3 electron. Now for the same, if you use the formula which we can use is again Q equal to NF. Q equal to N value is 3 because it has made use of 3 moles of electron, and F, so the quantity of charge required is equal to 3 Faraday, and the correct answer here is option C. Next question, question number 8. The cell constant of a conductivity cell. So the options given are option A, changes with the electrolyte. Option B, changes with the change of concentration of electrolyte. Option C, changes with the temperature of electrolyte. Option D, remains constant for a cell. So the cell constant of a particular conductivity cell never changes with the change in electrolyte. It never changes with the change in concentration of electrolyte. It never changes even with the temperature of electrolyte, but it remains constant for a cell. Hence, we can say that the cell constant of a conductivity cell, which is represented as G star and given by the equation L by A, is always a constant for a particular conductivity cell. Hence, the correct option for question 8 is option D, remains constant for a cell. Next is question number 9. Which of the solution of NaCl will have the highest value of conductivity, or even sometimes they ask it as specific conductivity, which is nothing but we represent by the letter kappa. So if you consider here, all are having different concentrations. So the one which has highest value of conductivity they have asked. So we'll arrange them in an order. So if you consider 1 molar is highest concentration, next is 0.1 molar, next is 0.01 molar, next is 0.001 molar. Now if you consider the concentration here, 1 molar is greater than 0.1, 0.1 is greater than 0.01 and 0.01 is greater than 0.001 molar. We say that we have studied a concept, or we'll relate and recall the equation. The equation was lambda m equal to molar conductivity is related by the equation kappa into V, where kappa is conductivity and V is volume. So on dilution, lambda m increases because volume increases, and if you rearrange this equation, we get it as kappa equal to lambda m by V, which indicates that on dilution, the conductivity, that is kappa, decreases as the volume increases. And considering this factor, since it is asked conductivity, we can say that more dilute the solution, less is the conductivity. More concentrated the solution, greater is the conductivity. And the reason for this is, when you dilute the solution, the number of ions carrying current per unit volume decreases. So the number of ions carrying current per unit volume are greater in 1 molar than that of 0.001 molar. So the solution of NaCl which will have the highest value of conductivity is 1 molar, and option D is the correct answer. Question number 10. Which of the statements about solution of electrolytes is not correct? So the options given are: conductivity of solution depends upon size of ions. Yes, it does. It depends on the size of ions. Conductivity depends on viscosity of solution. Yes, conductivity depends on viscosity of solution. Conductivity does not depend upon solvation of ions present in the solution. No, it's the incorrect statement. Means according to us, it's a correct answer. Conductivity depends on the solvation of ions. Option 4. Conductivity of solution increases with temperature. Even it is correct. So this is correct regarding the solutions of electrolyte. This is correct regarding the solutions of electrolyte. This is incorrect and this is also correct. So for this we'll refer our NCERT. Thus, here if you consider NCERT, the conductivity of electrolytic solution depends on nature of the electrolyte added, the size of the ions produced and their solvation, nature of the solvent and its viscosity, concentration of the electrolyte, temperature, it increases with the increase of temperature. So it is dependent on the size of ions and their solvation. It's dependent on viscosity. It is dependent on temperature. And hence, according to it, the correct answer what we had selected is option C. Conductivity does not depend upon solvation of ions present in solution. Next, question number 11. So if you consider question number 11, molar conductivity, that is lambda m value is given of a solution is 1.26 into 10 to the power 2 per ohm centimeter square per mole. Its molarity is 0.01 and its specific conductivity will be. Now how do we relate them? By the equation. So you should know the equation, that is molar conductivity equal to conductivity or specific conductivity into 10 to the power 3 centimeter cube per liter divided by the concentration in terms of mole per liter. So here lambda m value is given, that is 1.26 into 10 to the power 2 per ohm centimeter square per mole, which is equal to conductivity into 10 to the power 3 centimeter cube per liter divided by concentration is given as 0.01 molar, which we can write it as 10 to the power minus 2 molar. So 10 to the power minus 2 molar is nothing but mole per liter. Per liter gets cancelled. So if we send it to the other side, it becomes 1.26 into 10 to the power 2. If I raise it to the power minus 2 per ohm centimeter square per mole, which is equal to kappa into 10 to the power 3 centimeter cube. So here 2 minus 2 is 0. So it's nothing but 1.26. If I send it to the other side, here you get 10 to the power 3 units remaining per ohm centimeter square per mole, and here mole goes to the above here mole, and here it is centimeter cube. So if we solve it, centimeter cube goes up and everything if you solve, you get it as 1.26. 10 to the power 3 goes up, so 10 to the power minus 3 per ohm. Mole per mole gets cancelled, cm cube goes up, so cm 2 minus 3 we get it as minus 1. So per ohm per centimeter, and according to this, which is our correct option, the value is given as option B. So the correct answer is option. With the next question, the equivalent conductance of an infinitely dilute solution is option A equal to difference of ionic conductance, B independent of ionic conductance, C equal to the product of ionic conductance, and D equal to the sum of ionic conductance. And this is based on Colrausch law, which says that the equivalent conductance of an infinitely diluted solution is equal to the sum of ionic conductance. Sum of ionic conductance. So for example, if you take the equivalent conductance of an infinitely diluted solution of NaCl, it can be calculated as lambda naught of Na plus and lambda naught of Cl minus, that is the sum of ionic conductance, and here this we can represent it as lambda naught. So this naught indicates at infinite dilution. Next, question number 13. The highest electrical conductivity of the following aqueous solution is of. So the options given are 0.1 molar acetic acid, so which we can represent it as CH3COOH. Second, 0.1 molar chloroacetic acid, so this we can represent ClCH2COOH. Third, 0.1 molar fluoroacetic acid, so which we can represent it as FCH2. COOH, and fourth difluoroacetic acid, which we can represent it as F2COOH. Now the concept about it, we have discussed it in the lesson aldehydes, ketones and carboxylic acid, that greater the electronegative atom or more the number of electronegative atom on the alpha carbon atom, greater is the strength of the acid. So if we consider the strength of the acid, difluoroacetic acid is the strongest acid. And in first PU in the lesson chemical equilibrium, you have already studied that stronger acid will have greater dissociation or greater ionization, and greater the dissociation, greater are the number of ions in solution, and greater the number of ions in solution, greater is the conductivity. So here if you consider the question, if it is asked as highest electrical conductivity of the following aqueous solution is, so the answer here is 0.1 molar difluoroacetic acid, as it is the strongest acid. In case if they ask lowest electrical conductivity, then the answer would be 0.1 molar acetic acid, as it is the weaker or weakest acid among the four. So based on the concept of stronger acid and weaker acid, we can find out the highest electrical conductivity of any aqueous solution. So the correct answer for question number 13 is option D, 0.1 molar difluoroacetic acid. So we'll go with the next question. Question number 14. Which of the following statement is wrong? So option A, specific conductance decreases on dilution, equivalent conductance increases on dilution, molar conductance increases on dilution, specific conductance increases on dilution. So if we consider the equation, already we have discussed about it, that is lambda was equal to kappa, that is conductivity into V, or specific conductance into volume V. So if you consider lambda in terms of either equivalent conductance or molar conductance, the relation between lambda and volume V, that is, it is directly proportional to volume. And we know that on increasing the dilution, volume increases. If volume increases, both equivalent conductance is also increasing, as well as molar conductance is also increasing. But using this relation, if we find out the relation between kappa, that is conductivity, or specific conductance and volume, if we rearrange, we get the equation as kappa equal to lambda divided by V, which shows that conductivity is inversely proportional to volume. So if the volume is increasing, specific conductance is decreasing. Hence, the correct option is correct statement. These three are correct and the fourth sentence is wrong. Hence, the correct answer for the given question is option D, that is specific conductance increases on dilution, is a wrong statement. Next, question number 15. Cell constant has the unit. So cell constant anyhow you can calculate. One is either you can take G star is equal to L by A, or we know that G star is equal to R into kappa. So if you calculate by any of the way, you will get the same answer. So L is length and here all the units are in centimeter. So length if you take in centimeter, area will be taken as centimeter square. So centimeter square goes up, it becomes centimeter minus 1. Or by this if at all we calculate, so we know that resistance unit is nothing but what? Ohm. And whereas conductivity unit is per ohm per centimeter. Therefore, G star is equal to ohm into per ohm per centimeter. So this 2 gets cancelled. So what's the unit of G star remaining? Per centimeter. So either of the way if you solve, you get the same answer. And the correct answer for question number 15 is option B, per centimeter. We'll go with the next question. Question number 16. At infinite dilution, each ion of an electrolyte contributes a characteristic ionic conductance towards equivalent conductance of electrolyte, which is independent of the nature of the ion present in solution. This statement was given by, so at infinite dilution, it is equal to the ionic conductance of the electrolyte and it is independent of the nature of ion present in solution, is nothing but a statement given by Colrausch, which is called as Colrausch law of independent migration of ions. Hence the correct answer for question number 16 is option A, Colrausch. If we consider the next question, question number 17. For which of the following electrolytic solutions lambda m and lambda equivalent are equal? So lambda m refers to molar conductivity, lambda equivalent refers to equivalent conductivity. It is dependent on molarity of solution. It is depend on normality of solution. So if molarity and normality, when they become equal, or if the n factor, based on the n factor, we can calculate that is molarity equal to normality into that n factor. So if this value and molarity are same, then we say that equivalent conductance and molar conductance are equal to each other. And that n factors upon the number of ions, the charge on ions. If we consider here, we have Ba2 plus and here 2Cl minus. That means totally there is a charge of 2, either plus 2 or overall minus 2. If we consider KCl, K plus Cl minus, and here the value is equal to 1 because plus 1 minus 1. Al2SO4 thrice, so if we calculate, we get it as 2Al3 plus and 3SO4 2 minus, so its value is equal to plus 6 or minus 6, that is overall n factor is 6, and CaCl2 plus 2 minus 2, so its n factor is 2. Thus, molarity will be equal to n if the value of this n factor is 1, and we are getting this value for n factor as 1 for KCl. Hence the correct answer is option B, KCl. Next question, question number 18. The fraction of total current carried by an ion, so the fraction of total current carried by an ion is known as transport number of that ion. It is also called as transference number, or it is also called as Hitteroff number. It is called as transference number or Hitteroff number, and it is represented as T plus T minus or TC or TA. So the correct answer for question 18 is transport number of that ion. We'll go with the next question. The sequence of ionic mobility in aqueous solution is. So this ionic mobility means movement of ions. Movement of ion becomes difficult if the size of the cation is small. And if the size is small, it has greater tendency to undergo hydration. So it has higher hydration, higher degree of hydration. And hence, so these two decrease their ionic mobility. It decreases the ionic mobility. So what does it indicate? Instead of small size, if it is having a high or a large size, it will increase ionic mobility. Ionic mobility means movement of ion. And it will have low hydration in degree, that is degree of hydration decreases. And if degree of hydration decreases, ionic mobility increases. And thus we can say that larger the size of the cation, greater is the ionic mobility. Now if we see here, these are nothing but group 1 elements. The elements present in group 1 are lithium, sodium, potassium, rubidium, cesium and francium. So lithium is not included, but sodium, potassium, rubidium and cesium are included. So in this we have studied in first PU, that is as we move down the group, ionic size increases. So the ion with a larger size is nothing but Cs. So Cs plus is having larger size, means higher mobility than rubidium. Rubidium has higher mobility than potassium, and potassium has higher mobility than Na plus, that is sodium ion. And this option is given as option B. Hence the correct answer is option B. Next, question number 20. Variation of equivalent conductance with concentration of strong electrolyte is given by Huckel-Onsager or D by Huckel-Onsager equation, which is expressed as, so it's a direct question. It is applicable for a strong electrolyte and it is given by the expression lambda m equal to lambda infinity minus B into root C. So the correct answer for question 20 is option A, that is lambda m equal to lambda infinity minus B into root C. So thank you for watching.